Okay, so I'll get started now. The first group of people went through Lab 1 on Monday, and then today is for the second group of people to go through Lab. And what I'm going to start off talking about is the reading, and then after that I'm going to talk about the lab. And if we have any extra time, I'll start going forward into the second reading assignment and the second lab. So the purpose of the first chapter of the textbook, the recommended textbook, is to get a sense about the overview of what's going on. What is a computer? What's the basic organization of a computer? And what is the language C++? What does it mean in relation to what a computer is and how it's physically constructed? But it doesn't go into a lot of detail, and I'm not going to go into a lot of detail either. There are other courses that are taught here at the university that go into great detail about the physical structure of the computer and very low-level concerns about how the computer and the operating system interface with each other. And one course in particular that many of you will take is called Computer Organization, CSE313, and that's where you get that. It's a very good area to be strong in, and I do recommend that you put a lot of effort into understanding computing from that level where the hardware and the software meet that interface. And that's covered in that course that I just mentioned, CSE 313. Just to give a quick overview though, I made some notes about this, and I'll just briefly go over this. It's not something that you're going to be tested on, so you don't have to worry about recalling these facts in an exam. But the computer is divided into two main parts. There's memory, and then there's a central processing unit. And when the computer runs, there are computer instructions as well as data that's stored in memory. And those instructions are fetched and executed in the central processing unit. So you can visualize it as this CPU out of interacting, reading and writing with this long sequence of bytes. And what's stored in the bytes? Well, it's a combination of both data and computer instructions mixed together in the same memory. It wasn't always clear that that was a good way to physically design a computer. But at some point it emerged that that was the principle that we were going to follow to build computers, and that principle is attributed to a computer scientist named von Neumann. And so that basic architecture of a computer is referred to as the von Neumann architecture. So you've got a CPU that's fetching instructions out of memory and executing them. And normally what it does is it does it sequentially. It gets one instruction, carries out what it says, gets the next instruction, does what it says, and so it goes through it sequentially. But some instructions cause the CPU to jump to another location in memory and to start fetching instructions from a different location. So that's a very important property or ability. And that's where that enables looping or repetition, so that you can repeat a sequence of instructions over and over again. And that's without that, you won't get as much benefit out of automating information processing with a computer. So there These instructions that are sitting in the memory are called machine instructions, and those are the instructions that the CPU understands. The CPU does not understand C++. The CPU doesn't understand Visual Basic. It understands machine instructions for that physical processor. So the machine instructions on an Intel processor are different than the machine instructions on a processor in a Macintosh. I don't remember the name of the processor. They have different sets of machine instructions. And so the machine instructions are hardware specific. And you have a class of processors that different operating systems can run on. So you have a class of processor. Actually, the Macintosh is the same. Now it's the Intel based, actually. I mean, I'm old, so I'm thinking about the old days. In the old days, the Macintosh hardware did not have an Intel CPU. They had something else. Now they use the same machine instructions that Windows uses. But this CPU doesn't understand those high-level languages. That's what they're called. C++ is a high-level language. It's not a machine language. It's not a low-level language. And so you have programs called compilers whose purpose it is to take a high-level language, programs written in a high-level language, and translate those programs into machine instructions. And that process is called compilation. That means you can have a program written in a high-level language, such as C++, which is the language of focus in this class. You can have a program written in a high-level language and compile it in different architectures and produce different output, different files of machine instructions called executables. File of machine instructions is an executable. So it's the same high-level language, and yet it can be compiled on those different hardware platforms. That's one of the purposes of a high-level language. There's other purposes as well. For instance, a simple command in a high-level language may compile to many machine instructions. So it simplifies the task of automating the information processing tasks that you're doing. So you don't have to write in this difficult, low-level machine instruction. You can write in a higher level language, and it basically saves a lot of time. I'm going to go into that. So when you use this compiler, I have a note in here about assembly language. Assembly language is another language. It's a low-level language, and it's not machine code directly, but it's pretty close to machine code. It's essentially machine code. We're just using mnemonics instead of the actual numbers. Like EAX represents a register, hardware register, in the CPU, and this is a move command. We're moving the value 4 into the register whose name is EAX. So that's an assembly language command. And this assembly language command is translated into a machine code, which is just like 2 bytes, something like that. Depends on the architecture. Once again, this is a topic of that class, Computer Science 313. They call it computer organization. When you hear that word computer organization, you should think about it's a hardware course. So when you have this a file of machine instructions and data together, mixed together, that's an executable. And then to execute the program, you hand it over to the operating system in some way, like double-clicking on a file that ends with .exe or something like that. You tell the operating system that you want to execute this executable, and it does that, and it creates something called a process. So a process is a running instance of a program. So computer memory is based on zeros and ones. So it's binary. So you can think of computer memory as this big sequence of binary values. So so you start at normally you have what's called you've got this block of memory, and it's comprised of bytes, and a byte is 8 bits. A bit is a 0 or a 1. And these bytes, these 8-bit bytes, are sequentially organized. So they have what are called addresses. The first byte in RAM, or first byte in memory, has address 0. The second byte in memory has address 1, and so on. And so when you operate on a low, deeper level, that you're working with memory addresses. So you want to store a number in the computer. So you want to add 2 plus 2. You got to store the 2 in memory, store the other 2 in memory, and then use an operation to combine the 2 together, come up with a result, and perhaps store the result in another location. So when you write the program, you have to provide the numeric address of the bytes that will store those values. I don't want to get into too many details here. I'm just giving you the kind of like the flavor of it. We're actually not going to get into this. We're not going to operate at this level. It's not what we would call a lower level, but we'll get close to it. But it's good to have these concepts in the back of your mind as you try to solve problems, as you try to solve programming problems, and as you think about the operating system and so on. So a bit is a 0 or a 1. But we don't usually work with numbers. That's a binary value. So it's a 0 or a 1. But normally we group those together. So we have 2 bits next to each other. If you have 2 bits next to each other, that means you can have 0, 0, 0, 1, 1, 0, or 1, 1. There are 4 possible states that 2 bits can be in together. And so this would be the binary representation, 0, 1, for instance, of a value. But in our number system that we were taught, that we use, it was called a base 10 or decimal number system. 0, 1 would be a 1, and 1, 0 would be a 2. See, so you start 0, 0, and then the next value is 0, 1, and then you add a 1, and so it's a 0 or 1, so the 1 turns to a 0, and then you carry the 1. It's just like adding 1 to 9 and getting a 10. If you add 1 to 1, you're going to get a 1, 0. And then you add another 1, you're going to get 1, 1. So you start at 0 to get to 3. So 2 bits give you 4 different states, and those 4 states, we interpret them as the numbers, the integers 0, 1, 2, and 3. Here's another example. If you have 4 bits, and as the way we sequence these values, it's just like the number system that we use, the base 10 number system, but we're using digits that are 0 and 1. So we start with 0, 0, 0, add 1 to get 0, 0, 0, 1, and so on. We just go down the list here. And so we have 4 bits, that can be in 16 different states. Oh, I said 16 states, but the last value is 15, right? Well, that's because counting starts at 0. That's a very common issue. That's going to recur in the class about how that we start counting at 0. Humans start counting at 1. So I'm going to count something. Let's see, I'm going to count the number of erasers here. 1, 2. But the computer doesn't start at 1. The computer starts at 0. So if the computer counts the erasers, it's going to go 0, 1. Ah, there are 2 erasers, so it'll add 1. So it gives rise to what's called one-off errors. And you'll have to reason over these one-off errors all the time, even in the high-level languages. That's just that's a warning for you to think about. So, but normally, when you see representations of values that if you see representations of memory states or values that are stored in the computer, you don't usually look at it as a string of binary digits, but you could look at it as a hexadecimal value. So this hexadecimal means base 16 as opposed to base 10. So base 16 means, that one's digit, that one's place in the number is going to go all the way up to F, because when we hit 9, we don't want to go to we don't want to carry to the next place. We have to keep in the ones place. So we use, by convention, we start to use letters to represent values or digits. So this is the A is the 10th digit in hexadecimal notation. And then, of course, the largest digit in the hexadecimal notation is F. And that's decimal 15. But 4 bits is not what we normally use anyway. But 8 bits, that's common. So 8 bits, that's the length of what's called a byte. And that's a basic unit of computer memory. You could think of a byte and a bit as similar to a molecule and an atom. So an atom, you can't get any smaller than an atom. Well, you can get subatomic particles, all that. But you've got atoms and then the molecules that are comprised of the atom. So you have bytes, and they're comprised of these bits. And normally we work with bytes. Computer memory is addressed in terms of bytes, not bits. So the bits don't have a numeric address, but a byte has a numeric address. And so a byte is 8 binary values, and it follows the same pattern of incrementing and carrying and so on till you generate 256 different values. So a byte can be in one of 256 states. And hexadecimal representations look like this. So the largest value stored in a byte, an unsigned byte, is FF. All right. I talked about this already. This is, I'm not going to go over that. The CPU, it reads, no, I guess I am going to talk about it. It reads, it has what's called a fetch execute style. It fetches an instruction, executes it, and when it executes the instruction, what's the result of executing an instruction? Well, the result is modifying memory or loading registers. That's it. Or modifying what's called the program counter, which is the address of the next instruction to be executed. Once again, we're not going to go into those details, but it's very useful to learn that material. Assembly language, we already looked at that. So that is reading assignment 1. The due date for this reading assignment is today. All of you should log into Blackboard and check off that checkbox that you have completed reading assignment 1, assuming that you did reading assignment 1. So if you haven't yet, then get to that before midnight.
Have you heard or seen anything online about that?
What?
You said you can find it online.
What's that?
The book online. I remember you saying that we can find it online without like actually purchasing it.
Yeah, yeah. I want you to read about these topics. So if you did, were you here last time? You were here last time. So the question is, have you read chapter 1 or its equivalent? And so it's up to you to decide what its equivalent is. And I'm leaving that up to you to make that decision. And if you have some doubt about something, I want you to show it to me and ask if it's an equivalent or not. Yeah. But these texts are very standard. And you don't see a lot of differences. If you had a text from another course, a computer science course, then it probably looks a lot like the one that we're using. But if you're not sure, then show it to me. Any other comment? Okay. So Lab 1, what the purpose of Lab 1 is to get people comfortable with the command line interface to the operating system of your choice. And if you're working in a lab, then you're working with a Linux machine. Unless you're working on your laptop, then whatever is running on your laptop, you're using that. So that was the purpose of the lab, is to go over the meaning of these commands. And I'm going to show you a procedure. I'm going to log into one of the lab machines, and we'll just do we'll look at a few of these commands and talk about them. So how do I do that? Well, I'm going to use a terminal program. I forget what you call it. This is it's called PuTTY, and what PuTTY does is there's a lot of there's several programs that let you do this. So I'm going to make a secure connection to one of the lab machines and log in as me, and then we'll have a command line interface, and we can play around with that and see how that works. So let's see. Now the thing about the labs are behind a firewall, so I can't log in directly to a lab machine. I have to pass through this like a gateway, and the name of that the host name of that entry point into the network that the lab machines are on is JB. I just can't remember. Who knows this? JBH 3-1. Is that it? .cse.csusb.edu. I think that's what it is. Oh, there it is. JBH 3-1. I have it stored. So you would type your username just like in the lab. Oops. You can read that. My system is not working correctly. I have to hit Control-C for some reason. But your connection should be okay. That's a bug that I'm getting the system administrator to look at. So I use ls. I'm in my what's called my home directory. So pwd, print working directory. This is, there's this concept of a current directory. So we've got in operating systems maintain something called a file system. So file system is a component of your operating system. And what a file system is, at least all the file systems I've ever seen, is that it's a hierarchy of folders and files. So you have the root folder. And under the root folder, you have these top-level folders. And each of those folders has folders. And each of those folders has folders, like that. And the folders can have other folders, or the folders can contain files. And when you're running a terminal program like this, this is an interface. This is a command line interface. So we're issuing commands to the operating system. We're telling the operating system to do something, like print working directory, and it displays it. So this operating system has a concept of current directory. Now you're logged in. There's a process running that represents your logged in state. And that process is associated with a folder in the file system. And PWD tells you what that folder is. And you can see it. So the root folder is that initial slash there. That would represent the root folder. And then actually the slashes are delimiters. So they break up the string into folder names, like a comma or a period. So actually the string that precedes the first slash is you can think of that as the root folder. It doesn't have a name. It's an empty string. And then under the root folder, there's another folder called U, and so on. So we can look at what's in the root. If I go ls slash, that these are the folders or files that are contained at the root level. Let me just change the font color. Clear. I think clear works. Yeah. I just want to reset the screen. So these are commands that you can issue inside of a terminal process on Linux or on OS 10. And these are the corresponding commands that you could issue on Windows. So for instance, on Windows, how to get to the command line processor? Well, it used to be in here, but I don't know if it's there anymore. There, command prompt. But actually, I've seen systems where the command prompt does not appear there. And then you would start it up by typing in CMD. This is the command line interface on Windows. LS is not available, but DIR is the equivalent on Windows. But LS and DIR are not identical in their behavior, so you have to keep that in mind. They don't do exactly the same thing. Like ls takes these arguments, like -l. That's the long list. Give me more information. DIR doesn't have that. At least I'm not aware of it having that. And -a is a show all, show hidden files. I don't know how to do that with DIR. Maybe there's a way to do that. Oh no, DIR shows the hidden files automatically, so you don't have to tell it to show the hidden files. It's already displayed, and so on. So there are these differences. CD and works identically, and make directory works identically. Deleting a file has a different form, and so on. And so these commands, you can issue these commands, move around the file system and do things. And you can store those commands in a file and then have all the commands in the file execute at one time. And that's the purpose of the second exercise, to write a script file to do that. Is this worth going over? To me, it's like really common knowledge, but maybe all of you don't know this. You have a question?
The software PuTTY is only for Windows, right?
Yeah, PuTTY is only for Windows. If you have Macintosh or Linux, what you need is already there. Use SSH. It's already installed. If you have a Macintosh machine, just type in, get a terminal window, go SSH space JBH3-1, like that, dot. Or if you're a Linux, I see there's a bunch of Apple computers back there. Try SSH. So, do you want me to go over script files, or is that? Yeah? Okay. All right, let's do that. All right, let's go to, let's work in the lab first. And I'm going to make a directory called temp. It's probably already there. Oh, it's already there. I'm going to cd into temp. I'm going to look what's in there. Man, I don't need it. This is a very dangerous command. Whoops. I don't recommend actually running this command. If I did that in my home directory, I would lose everything. And it doesn't even, and there's no trash. There's no recycling bin to get it out of. This would wipe out everything. And it's remove dash recursive force. Force means don't ask me, just do it. Recursive means delete what's where I'm at now and all the folders and their subfolders. And star means everything. But it's not going to go up. It's just going to go down. It's going to delete everything where I'm at, and it's going to go down. Because this is big. There's a lot of stuff there, actually. And I know I can do that because I named it temp. Oh, this scares me. Well, it's doing a lot of work here. So that's a dangerous command. And it's taking a long time. CVS. Well, let's go back to here. Well, that's working. We're inside Windows here. And let's make a directory called temp here. I'll cd into temp, so that's like change directory temp. And pwd, you don't need to run pwd. You can see the path right here is in the prompt. C users turner temp. Oh, it completed. Finally finished. Let's make sure that it finished. I'll do ls. Yeah, if I do ls minus a, I'll show the hidden files. Oh, dot and dot dot. Those are entries that are listed as part of the contents of my current folder. What do those entries mean? Well, dot is just names the current folder. So dot just means the where I am now, and dot dot is refers to the parent. So if I do ls dot dot, I'm saying give me the contents of my parent folder, and you'll see inside here I should have temp, and there it is right there. So this is where that's our current directory, but I listed the contents of my parent, so my current directory is in the parent. If I do ls dot, well, that's the same as ls, right? Well, there's nothing there. Let's see, on Windows, dir. Well, look at that. Windows has exactly the same convention. Dot and dot dot. Dot represents the current directory, and dot dot represents the parent. I go dir dot dot. See these files that start with a dot? On Linux, those are hidden. On Macintosh, those are hidden. Those are called hidden files. By convention, if a file name starts with a dot, Macintosh and Linux will interpret that as a folder or a file that should not be normally by default displayed to the user. But Windows doesn't. Windows has a different concept of hidden. Actually, I don't know how you do it from the command line, but I know you can. From here, you can look at a file like this and look at its properties, and you'll see whether it's hidden or not. Well, this one is hidden, in fact. I can see it. I can see it because I want to see hidden files. It's important for me to see hidden files. And I do that here. By default, don't show hidden files, folders, or drives. That's selected by default. But whenever I install the system, I just go ahead and set that, change that setting, and make it global for my whole file system. The other thing that's a very important setting for programmers. So this is an important setting for programmers. Another important setting, and I recommend that you do this, is to remove this checkbox here. Hide extensions for known file types. That's a source of a lot of bugs and wasted time. Take that off because I want to be able to see what the file extension is. I don't want Windows to hide it from me. So let's talk about scripts. So look at, let's suppose we did this. Let's suppose this is what we want to do. We want to list the parent, and then we want to list the parent's parent. Remember, folder names or items, file names, entries on what's called a path is a file system path. Those entries have a delimiter. They're separated by slash. On Linux and Macintosh, it's forward-leaning slash. On Windows, it's a back-leaning slash. But these days, I think Windows is starting to recognize the forward-leaning slash as well, so that's convenient. We'll test that. Let's test that right now. If I do dir ... /... That's the Linux and Macintosh style. Actually, it's called a Unix. Right? Macintosh operating system is based on is called a Unix variant. Linux is a Unix variant. They're all Unix style operating systems. This is the convention for Unix. Invalid switch. See, it doesn't take it. At this level, it requires a backslash. So in the command line interface, it does not accept a forward slash as a delimiter in a file system path. All right, let's clear that. Oh, let's do this. So we have, I'm going to use the up arrow here. This is called the command history. See that? And so that's very convenient when you're working at the command line. You can use the up and down arrow to scroll through a record of commands that you submitted in the console window. So then it helps you, that helps you save a lot of typing. Another trick to save a lot of typing is using command completion. And that's where you type in half of what you want or one character of what you want. You have some partial command typed out on the command line. Hit tab, and the terminal window tries to guess what you want. And I'll give you an example. Well, I'll give you an example later. So we've got two commands. If I just do ls ... and then I do ls ... /... I get a screen that looks like that. So I'm doing two commands. Let's just pretend that I want to do these two commands all the time. And I don't want to have to type them in over and over again. So I'm going to write a script file. And I'm going to use VI here. This is called a text editor. It's not an editor that I recommend for someone who's not a computing major. But if you're a computing major, then VI can be a very useful program to learn, but it's difficult to understand, to tell you the truth. Well, there's alternatives. You can use Pico. I don't know if Pico's installed, and then you've got Nano, and there's different programs. It depends on whether they're installed or not. But VI is always installed. It's on Macintosh, it's on Linux, it's on every Linux variant that I've ever seen. It's everywhere. And that's why VI in particular is useful for system administrators. System administrators will log into remote systems frequently and need to modify files, and they use VI. You know VI is there. Maybe they like to use something else, but the VI is reliably always present. So I'm going to use VI, and I'm going to create a script called doit. Now I'll call it list. Call list, and I'm going to use a file extension sh. That's for shell script. So that's the convention on a Unix style system, is to use .sh to label a file that functions as a shell script. So we list the parent, and then after we do that, we list the parent's parent. I don't need that. You know, sometimes that matters, that extra line return there. It doesn't matter here. Hit escape. That's right. Now what you don't see, this is called a text editor. So what text editors do is They're programs that are used to modify character files. We've got files that are comprised only of character data. Those are called character files. You use text editors to modify them. Well, let's take a Word document. Is a Word document a character file? No, it's not. A Word document is not comprised of character data. It's comprised of binary data. It's a binary file. It's specific to the, its format is designed just to work with Microsoft Word. Something to keep in mind. And let's save this and quit. I'm going to do ls. There's the file. I'm going to clear here. I'm going to do ll. That's a long list. What's the same as l minus l? Actually, let's do it like that. I'm sorry, ls minus l. And this is a long listing. It shows that there's one file, list.sh. This is when it was, I think it means when it was last modified. And this is the owner of the file, Turner. This is the group. So each object in the file system has an owner and a group. And owners and groups and everyone else, those are the three categories, owners, groups, and everyone else. They have permissions. So every file and folder in the system has a permission relative to those three groups. And those permissions are displayed here. So the first, this dash here, that's some other information. I'm not going to get into that. But the three characters right there, those are the permissions for the owner, which is Turner in this case. It's read, write, execute. Oh, so the third slot there is shows that the execute bit, they call these bits, the execute, because internally it's represented using bits. The execute bit is not set. Can you see this, by the way? Maybe it's hard. I should work like this. Is that better? I'm not looking at my own screen up there. Is that easier to look at? So I cannot run this file. So I'm trying to do I'm pressing tab to do command completion, because normally the system will just complete this command for me. But see, the list is not it's not an executable. So we don't have the execute bit set. So I'm going to modify that. I'm going to do mod plus x, plus x list. Watch as I do L. I'm going to hit the tab key. That's command completion. There was only one thing that matched against that leading L that I had there. So the system said, well, you must want the file list. Nope. Wait, I got the wrong command. What is it? How do I set the file? What's that? Oh, chmod. Yeah. How could I forget that? I'm doing this my whole life. Okay, so there we go. Now I'm going to use the history key here, and oh, there it is. There's the execute bit. In fact, the execute bit was set for all users, which is these three slots right there. Read, write, readable, writable, executable. Well, it's readable and writable by all. I'm sorry, it's readable and executable by all, but it's not writable. So other users cannot edit the file, cannot modify the file. And users that belong to the group users, those users can also read and execute this file, but they cannot modify it. But Turner, who's the owner, and the owner's permissions are designated here by these three characters, the owner, Turner, can read, write, and execute this file. Because what we needed there was just to be able to execute. And now when I go dot slash, see the dot, what's the dot here? It means current folder, the current directory. So the system wants to know the fully specified path to the command that you're issuing here. So it's list but I'm going to use tab here. Oh, now I know that I got it right. I got the permissions right, otherwise the system wouldn't let me do command completion there. And then I'm going to run that, and I get nothing. What's going on? Is it just a network failure? I think there's a network failure. Let's look at Windows. Oh, CLS, that's clear on Windows. And VI, I don't have VI on Windows, that's not there. And there's a way to create a file, batch file in Windows, and there's a command that I can launch like Notepad. Does anybody know how to start Notepad from the command line? Is it? It's not, I don't think it's just Notepad, right? Maybe that's it. And we'll call it list.sh. Oh, we don't want to use .sh. It's not the convention on Windows. The convention is BAT for batch. I say batch file. Let's see if that works. It worked. Cannot find list.batch. Do you want to create a new file? Yeah, let's do it. And let's try dir dot dot and then dir dot dot backslash this time dot dot. Let's try this. And I'm just going to put a little new line character there, although I don't think it matters. dir, there it is, list.bat. Now that's in there. I'm going to clear the screen. Let's run it. Dot slash. Do we need that? I don't think we need that. We just type in list.bat. And there it is. It ran it. As you can see, list.bat, it shows you the command that runs. dir dot dot, then there's the output, and then there's dir dot dot slash dot dot, and then there's the output. We're still nothing is working here. What is going on? Oh, so I'm here. Cat, this is concatenate contents of a file with the standard output stream. That should work, right? Why is that not working? That's crazy. Okay. I'll have to look into that later. Why would that not work? That's so weird. Let's try a different command. I cannot run anything. I wonder what's going on. All right. I'll have to work on that later. Is anyone else logged in to well, I'm on JBH3-1, right? That's not advisable. See, this inside the Linux prompt here, it shows the host name. This is I'm logged in as user Turner on host JBH3-1. We actually want to SSH secure shell. This is what you would do on a Macintosh. Secure shell JB359-1. That's the name of the room, JB359. Let's go on computer JB359-4. They're numbered like that. There's -1, -2, -3, and that would be. This is the complete path name here. But you know, this is the same network as JBH3-1, so I don't need that part of that path. This is sufficient. Oh, does this happen to anybody? Back there? Okay, I'll show you how to fix it. So this system, I've logged into JB359-4 before, and since then, that system has been reinstalled and its security credentials have been regenerated. So it has new security credentials. My system has cached the old security credentials and it says, warning, the security credentials have changed. I'm not going to let you log in. So we have to edit in the home directory. I'm going to use tilde there. Tilde is a character represents the home folder, home directory. I'm going to edit a file that's inside of a folder under my home directory. And it's a hidden folder, so it starts with a dot, and it's SSH or something like that. It's SSH, I believe. Well, I pressed tab twice, because that dot S matched against a bunch of different possibilities. So it's showing me all the possibilities. So these are all of the hidden files and folders that are in my home directory. And this SSH, I believe it's using the SSH2. So I'm going to go into that folder. I'm going to hit tab twice. I hit tab twice because I want to see what's in there. And I don't see what I want. Maybe it's in SSH. There it is. Known hosts. Known hosts. Known host 2. Which one is it? Here it says known host up there. It's showing you add correct host key in this file to get rid of this message. So in fact, if we just read that text up there, we'll see that this is it. So these are the cached, what are called public keys. So, you know, security is based on cryptography, and network security is based on cryptography, and cryptography relies on the use of what are called public-private key pairs, which we're not going to go into, but these are in fact the public keys, or some version of the public key, like a certificate that contains a public key that's used to authenticate the other computer. Let's take a look at this. It should be in here, right? It should be one JB. I don't know which one it is. I don't think it's in there. Let's look at this message again. This host here, does it have an IP address? Maybe it's cached by IP address. So I use this dig command, and I want to find out what its IP address is. And I see that I don't understand it. Does anyone see it in there? That is not it. What's the command to look up a host name? Anyone? NS lookup. That's the old one, right? JB 359-4. This is the address 2.1. Oh no, I'm sorry. That's the router. Here's the address. It's 139.182.148.124. This is the IP address of that computer that we're trying to connect to in the lab. Oh, forget to look at it. 148.124. You see that in there? 148.124. There it is right there. Do you see that address? Oh, there's the number right there. JB 359-4. I didn't see it before. I'm just going to delete that line. And now we can connect. Now I'm going to reissue this. Let me show it first. I'll clear. I'm going to reissue that command. SSH JB 359-4. See, this is saying, hey, I can't find that public key in the file that we just edited. And so, well, let's insert a new one in there. So it's saying, oh, this is the first time you contacted this computer. We don't have a record of its identity as established through its certificate or its public key. And I'm gonna say, yeah, go ahead. It's unsafe. You know, this is unsafe to do, but we're gonna go ahead and do that. Now with my password. And it's unsafe because there could be what's called a man-in-the-middle attack. You know, maybe I'm not really connecting to that computer. The only way to know I'm connecting to that computer is if I had its public key in advance. But I just deleted the old one. So I'm just going to trust the network that there's no man in the middle between my computer and that one. But there might be. But it's kind of, yeah, it could be. So so we're logged in. As you can see, we're now logged in to that host, and that's in the computer lab. Let's see if anyone is logged into that machine. I'm the only person logged into the machine. If you run users, you can see if someone else is logged into that machine. If someone in the class right now wants to log into that machine, someone give it a try. Someone we'll see you up here. Will someone please try to log into JB 359-4? Looks like one person is working back there. Can you log in? Not yet. There's a contest. Oops. Not yet? Someone log in? Oh, brave soul. I don't see keyboards going back there. Where's your sense of competition here? All right. Anyway, we're there. We're logged into that remote machine, and maybe now I want to show you something that inside here I've got temp, and we're on a different machine, right? Well, look, list.sh is there. Why is it there? Because all the machines in the lab, they have what's called a shared file system. So if you log in on one machine, you get your home directory is actually residing on a server on one machine somewhere, and the memory, the disk space memory that's on that file system server is presented to you transparently as part of your local storage. But actually what we're doing here, when I do LSH and I say what's the contents of this folder, there's a network communication. So the local machine that we're logged into in the lab goes to the file server and says, you know, what's the contents of this folder, and it returns the message and say, oh, there's a file in there called list.sh. And I go, oh, I'll display that to the user to let the user know that that's what's in there. But this whole time, that's all transparent. So we don't know if we're looking at local storage or remote storage. There's a way to find it out. You know, this is a topic of system administration. That's what we're doing right now. All of today is talking about system administration. And if you're getting overloaded here, I want to de-stress you by saying that all of what we've covered so far is not going to appear on any exam. I'm just trying to get you exposed to these concepts and make you comfortable with some of the tools that you're going to be using to write programs and test and run them. And these techniques and concepts you can pick up on your own, and you can also get them in some of the courses some of the other courses that we teach here. Let's see if we can run this command from the lab machine. There it is. See, there was a problem. I see the system administrator doesn't want people just logging into the gateway machine and running commands there. So he did something to block me from running my shell script. He's saying, I don't want you. You know, he's trying to get us to log into one of the machines to take the pressure off that one entry point. Otherwise, everyone's working on one machine. That's too much. Too much memory and CPU usage on the entry point machine. So that answers that question. We did some detective work on that, figure out what's going on. So let's finish up with this, and then we'll get out of here. I'm going to copy that. This is your standard hello program. Well, it's a by program. Let's turn it into a hello program. So usually when you're learning something, so a new programming language, the first thing you do is you write a hello program. You run the program, it says hello. So let's do that. And let's do that on the lab machine. And let's go ahead and create the file called hello.cpp. And I'm going to paste in that code. And ls, I use that a lot just to see, just to verify. Yeah, there it is. I put it there. Now this is not an executable. I can't go, I can't execute the file. Permission denied. See, I don't have execute permission. The execute bit is not set. It doesn't need to be set. It doesn't contain machine instructions. It's got character data. So we need to compile it. G++ hello.cpp. So G++ is a command to start the C++ compiler. So we're telling the compiler, here's a file. Translate this file into machine instructions. It did it. If there was a problem, it would say there was a problem. If there's no problem, it just silently finishes. I'm going to do ls to see what's in there. Oh, there's a new file, a.out, got created. This is the file that the compiler produced that contains the machine instructions. That's an executable. Let's do the long list on that to see the permissions. When the compiler created the file, it knows that it's an executable, so it sets the execute bit for us. So there has an execute permission there. We'll use dot. It might be, we may not need that dot slash. No, we do. We do. We need the dot slash. And the reason we need the dot slash is because our path doesn't have dot in it. The path is a collection of folders, it's a collection of folders that the system scans to find commands. And dot, if you put dot in your path, it will check the current directory to find commands to execute. But my path does not have a dot in it. How many people understood that? I saw a hand. So once again, you'll get this over time. And I don't want to belabor the point here and go into a lot of the details, because a lot of this information I'm giving you now really can't be absorbed very well in a lecture. It's absorbed in a lab. It's absorbed while you're working on a computer. And that's one of the reasons to come to the lab, actually, rather than doing the work at home, is because you can access the help that's provided in the lab. And you can help each other as well. All right, let's run it. And there it is. It says bye. Oh, we want to say hello. So I'm going to go ahead and modify that. And I changed it. Now it says hello. That's what the assignment calls for. It's a hello program, not a bye program. Now we're going to run it again. Anybody see a problem? It still says bye. Some people do this, right? I mean, every quarter somebody does this. What happened? I need to compile it. I modified the source code. I didn't run the compiler to translate the source code into the executable again. So it's the old executable. So we ran the compiler again. Well, now it says hello. Okay. Our assignment is completed. We wrote the hello program. And that's it. That is lab 1. That took the entire period to talk about. Let me just tell you where we're headed with lab 2. Reading 2. Well, reading 2 is just reading. And then lab 2, we're going to use something called Subversion. It's a version control system. And on Windows, it's going to be pretty easy to use. On Linux, it's going to be more difficult to use because we have to use the command line to interact with the repository. And I'll talk about this next time, and we'll walk you through the process of using this source code repository. You'll be submitting your work through this through your repository in this class. I already emailed everybody their username and password. Did everybody get that email? How many people got that email? Okay, so if you don't have that email, you have to talk to me. There's someone in here, I got an email, I think it's you. What is your name? Like Prakash or something like that? Your name. Are you Prakash? Someone like Prakash, has the name Prakash in it? Something like that. It's an Indian name. That email is bouncing on me, but everyone else, the email was accepted. So save that email, write down that password, and you will need it next week. That's it.